A 5 kilogram box is being pushed forward with a 100 Newton force for a total time of 1 second. The box is then pushed backwards with a force of 3 newtons because of friction. First, find the coefficient of friction of the box. Next, find the total distance the box travels after being pushed. Next, we must find the total force acting upon the box due to gravity. To do this, we take the weight of the box, 5 kilograms, and multiply it by 9.8 meters per second. This gives us 49 newtons, both the force acting upon the box due to gravity and the normal force. Next, we take the normal force and divide it by the force of friction. This gives us a coefficient of friction of 16.33. Next, we must find the acceleration of the box in the forwards direction. To do this, we take the force of 100 newtons and divide it by 5 kilograms. This gives us a total acceleration of 20 meters per second squared. This also gives us a total speed of 20 meters per second as the box is only pushed forwards for a total of 1 second. Next, we must find the deceleration of the box due to friction. To do this, we take the force of 3 newtons and divide it by the weight of the box, 5 kilograms. This gives us a total deceleration of 0.6 meters per second squared. Next, we need to find the total time it takes the box to decelerate to 0 meters per second. To do this, we take the initial speed of 20 meters per second and divide it by the rate of deceleration, which is 0.6 meters per second. This gives us a deceleration time of 33.33 seconds. Next, we can begin work on the displacement equation. To do this, we take the deceleration time of 33.33 seconds and multiply it by the initial speed of 20 meters per second. Upon doing this, we get a total distance of 666.6 meters. Next, we can work on the second half of the displacement equation. To do this, we take 1/2 the rate of deceleration, 0.6 meters per second, and multiply it by the time it takes to decelerate squared, in this case 33.33 seconds squared. Upon doing this, we get a total distance of 332.7 meters. Finally, we take the initial distance from the first half of the equation, 666.6 meters, and subtract the distance we got from the second half of the equation, 332.7 meters. This gives us a total distance of 333.9 meters.